In this video, we're going to be taking a look at a torque problem where we have a beam angled at 40 degrees holding up a 40 kilogram crate, and we're going to find the tension of this cable up top. So what we're going to do is we're going to have to use a few different ideas, but we definitely know that the net torque of the entire system is 0 Newton meters because everything's at rest. Now, there are two ways to find torque. One of them is to find the force perpendicular to the actual object. And the second one is to find the force acting on it and the perpendicular distance to the pivot point. So we're going to use the second method. And once I draw out some vectors, it'll be a little bit more clear what the method is. So we have three different things providing a torque. We have this cable, obviously, which is one of the main things that we're going to be solving for. We have the force from the crate hanging right here. And then we have the mass of the beam itself. So it's 100 kilograms. So if we just take the center of it, it's going to have a torque pulling it down from that position right there at the center of the beam. Now, what we want to do is find some different distances. So far, we know that the length of the actual beam is 5 meters. So this 5 meters over here is basically the hypotenuse of the triangle. And if we use the sine of 40, we can find this distance up here, which would be 3.21 meters. And if we use the cosine of 40 times 5, then this distance right here would be 3.83 meters. All right, so now that we have every side of our triangle, we're good to go for all of our distances. And this 3.21 across the top would be same as 3.21 across the bottom. And this 3.83 along the side over here would be the same thing as 3.83 along this side as well. So here's what we know. We know that the torque from the cable, we'll call that TC, minus the sum of these two over here, the torque of the beam itself plus the torque of the crate. So we'll say CR for crate, and then we'll say C for cable. So we have two negative torque values and one positive. So anything that's going counterclockwise is positive, and anything that's going clockwise is going to be negative. In this case, it doesn't really matter that much because the sum is going to be 0 anyways. So the sum of that is 0 Newton meters. Now, for each one of those, we want to find the force acting on it along with the lever arm. So we're going to find the force and then the perpendicular distance of that lever arm to the pivot point. So the pivot point is right over here. So for this force, we're going to be using this distance right over here. And then for this force, we're going to be using the full distance from here to here. And then for the final one of the cable up top, it's going to be from here to here. So we're taking a look at each of the forces, and then from those forces, the perpendicular distance to the pivot point. So let's go ahead and write those out and see what it looks like, and then see if we're able to solve for our tension from there. All right, so for the torque of the cable, we have the force of tension, which is what we're looking for, the T. And then from there, the perpendicular distance to the pivot point was 3.83, which we found a little bit earlier. And then we have the torque of the beam itself. So that's going to be mg, so the 100 kilograms times 9.8. And then this purple distance that we said was 3.21 earlier, I cut that in half to find the center of the beam. And then for our final one, the torque from the crate, that's going to be 40 times 9.8. So basically the mg for the crate, which is the full 3.21 distance away, this purple line from the pivot point over. From there, if you multiply all these things, add them up, then there is a total torque of 2,831.22 Newton meters, which is subtracted from this side. So I added it to the other side and then divided both sides by 3.83 meters, and I got a final tension of 739.22 newtons. So when taking a look at a static equilibrium type problem like this, we have a bunch of different torques. So you want to make sure you identify which ones are pulling it or pushing it counterclockwise and which ones are pulling it or pushing it clockwise. And then basically subtract the ones that are working in opposite directions from each other and add the ones that are working together, and then set them equal to 0. From there, we were going to plug in our forces and our lever arms, and then from there we were able to find the tension of 739.22 newtons. So I hope that was helpful to you. Thank you for watching and listening.